All right, this is still lesson 7-2, number 8. Now this problem could be done using horizontal or vertical slices, but right now I'm going to show it using vertical slices. And we're going to do it without a calculator. The book is nice and gives us the graphs. Tells us this curved graph is y equals x squared. This straight line graph is x plus y equals 2. If I'm going to use vertical slices, I'm going to be, for example, drawing a rectangle like that. So the skinny dimension runs sideways. So is that a dx or a dy? That's a dx. If the skinny dimension runs sideways, that's a dx. That tells us that we're going to do our integral in terms of x. That means our bounds are going to be x's, our function is going to be in terms of x, and we're going to have a dx for the width. Which means we're going to do top curve minus bottom curve. So I'm going from here to here. So to get that distance, the top curve would be x squared. If I'm on the x-axis, what's another name for the x-axis?
Y equals 0.
Y equals 0, right? So really you'd be doing x squared minus 0 in this case. Now, I really can't do the whole thing at once, because once I get to 1, right here, the top curve changes to something different. So what I'm going to do first is just find the integral from 0 to 1. That'll give me just this left piece of area here. So what's the integral of x squared? What's the antiderivative of x cubed?
1/3 x.
1/3 x cubed, good. And then the minus 0, of course, will just drop off. And then we're going to go from 1 to 0. This is out of the way. So I'll plug in 1. You get 1/3 times 1 cubed minus 1/3 times 0 cubed. So that gives you 1/3 minus 0. So this area right in here is 1/3. Any questions about that? Now, the second piece, if you were going to do it with an integral, you could do that. We know we want to use vertical slices again. So we know our skinny dimension is going to be a dx. Our height, top curve minus bottom curve, but if I'm going to do it in terms of x, then I need to solve this for y. So what would y equal here if I solved it for y?
2 minus
Y
x.
equals 2 minus x. So if I was going to do it with an integral, my top curve would be 2 minus x. My bottom curve would be y equals 0 again. So minus 0 would be 2 minus x still. And then you could do the integral and you could plug in, what numbers would you plug in this time? 1 and 2. Yeah. But in reality, I mean, we could do that, but isn't there an easier way to do that, this problem? Isn't there an easier way to find this area? Yeah, it's a triangle. Let's just use the formula for a triangle, okay? If there's an easier way to do it, use it, okay? So it should tell us the height here in the book, I think. Otherwise, we can figure it out. Yep, the height is 1. The width of this triangle goes from 1 to 2 is going to be 1. So if it's the base is 1 and the height is 1, what's the area going to be? Right. 1 times 1 divided by 2 would be a half. So we're going to end up taking 1/3 plus 1/2. Use a common denominator. Common denominator would be 6. So it would be 2/6 plus 3/6. Final answer would be 5/6. And probably tomorrow we'll do the area running the slices horizontally, and we'll get the same answer of 5/6. Any questions about that?
So you just want us to do it with respect to x?
Yes. Yep.
Marty, do you